Hello, Mr. Vessel here today, and I'd like to take the next couple minutes and look at the 2015 AP Stat with some probability tasks, some basic, some conditional, and then even some expected value tasks in here as well. Starts up with information about a shopping mall that has 3 ATMs. Because the machines receive heavy use, they sometimes stop working and need to be repaired. Let the random variable x represent the number of ATMs that are working when the mall opens on a randomly selected day, and the variable shows the probability distribution of x. So I've already defined for us what the random variable x is, so I'm going to be using x in this particular task. I don't have to redefine a variable for myself here. And it looks like there's 4 possible outcomes. Essentially, it's either going to be 0, 1, 2, or 3 that will be working. And then we have the probabilities associated with each of those, and these are going to add up to 100%. They don't tell us that in the chart down here. We don't get a total, but these do add up to 100%. So part A asks, what's the probability that at least one ATM is working when the mall opens? Just be careful. This isn't a hard question, but just making sure that you're careful about reading it. And we also want to make sure that we use the correct notation here. It says at least one, so I want to find the probability that x is greater than or equal to 1 here. And it is just the sum of these 3 numbers. It could be 1, 2, or 3. And this number totals 85%, or 0.85. And that's a pretty straightforward task. Basically, we just want to identify like what did we calculate and what that value is. So 85% of the time, at least one's going to be working. Part B is an expected value task. Expected value, really just with probability like these, are just weighted averages. So we get all of these values, but we have different weights. So we can't just add up 0 plus 1 plus 2 plus 3. We have to weight them by the probabilities. So to get the expected value, which is the expected value of x, we're going to take each outcome, 0, the first case, it's weighted with a 15% probability. 1 happens 21% of the time. 2 is 40% of the time. And 3 is 24% of the time. And in this particular case, I'm just going to get the total here. So 0 times 15 plus 1 times 21%, and so on. It actually comes out to be 1.73. So this is our expected number for number of ATMs. So this 1.73 is kind of interesting, and one thing that's, they could ask lots of follow-up questions, I suppose, or parts C and D here, but sometimes you get questions about interpreting this number, and it's interesting with these discrete possible outcomes. With discrete probabilities like 0, 1, 2, 3, a lot of time the expected number is an impossible outcome. This is just a long-run average here. So if you were to collect data over maybe a year or a long period of time, you'd get an average of close to the expected number of ATMs on a given day, but it's not possible to have 1.73 ATMs working on a single day. So again, expected value is a long-term expectation, not a short-term expectation. And then the third part here, what is the probability that all 3 ATMs are working when the mall opens? And we know that number here, but it follows that with given that at least one ATM is working. So it's a conditional probability, and it's a condition based on at least one. So we want to find the probability that all 3 are working. So I'm going to write that part down here. So we're going to find the probability that all 3 are working, but it's based on a condition that at least one is working. So we don't need the entire sample space here. We just need to start with the probability that at least one is working. So in this particular setup, we had that number from part A actually. So 85% of the time, at least one of these machines are going to be working. But out of that 85%, that's where the exactly 3 comes in. 0.24 out of the 85% are going to be the 3 that are working out of at least one working. So this number comes out to be 0.2824. So about a 28% chance, a little bit more than that, that all 3 will be working given that one is working, at least one is working. And then the last part here is another condition, but it's about expected values. It's kind of an interesting task. You don't see this kind of question on every exam for sure. It says, given that at least one is working when the mall opens, would the expected value, the number of ATMs that are working, be less than, equal to, or greater than the expected value from Part B? And there's a couple of ways we could go do this. One way is to just calculate it, and I think that's a perfectly fine way to go about it, but it's really unnecessary in this case. So here's what we know from Part B, is that 1.73 is the expected number. And one way you can justify this, if you were to just eliminate all the zeros and recalculate the probabilities of 1, 2, and 3, if this is an impossible event, all of these probabilities are going to be a little bit higher. They're still going to be a little bit more in each case, and that's going to definitely increase this expected value from Part B. But really all we have to do is just say what the answer. In this case, it's going to be greater. So the expected value of ATMs would be greater than the expected value from Part B. And really, we can justify it by just mentioning the fact that since 0 is no longer an option, the other options of 1, 2, or 3, their probabilities will all increase. Will all increase in likelihood, increasing the expected value. And that's perfectly good for full credit in this case. We don't actually need to go through and do the calculation. We got to be able to say is that it's got to go up, and the reason it's going to go up is we're now eliminating all this possible outcome for 0 ATMs working. All of these other probabilities are going to increase, and if that's the case, if this is a higher probability, and this is a higher probability, and this one's a higher probability, well then this expected value's got to go up. It turns out we can calculate it, but we just don't need to. If you do calculate it, I think the number comes out to be 2.04, so that might be a good exercise if you wanted to try that. Calculate it out. The new expected value is 2.04. So give that a try if you'd like, even though it's not vital to get full credit for this particular exercise. So that's the 2015 problem number 3. I'd like to say thanks for checking this video out, and feel free to check out more and subscribe if you find this helpful information. Thank you.